Okay, so today we're going to learn about systems of equations. Okay, so a system of linear equations is a set of two or more linear equations containing two or more variables. Okay, all that means is that we're talking about a set or two different equations that have the same solution. Okay, so for instance, this one. We have x plus 2y equals 6 and x minus y equals 3. Okay, the solution is an ordered pair that satisfies both of these equations in the system. Okay, so for instance, let's check the solution for one of these two equations. Okay, so I'm going to plug in for one into both equations and see if it makes the statement true. Okay, so for instance, let's see. We have an x value and a y value. Okay, so we plug 4 in for x, 1 in for y. Okay, 4 plus 2 is 6. Okay, so it satisfies that equation. Okay, then we plug it into the next one. So 4 minus 1, is that equal to 3? It is. So it satisfies both equations. So 4, 1 is a solution. Okay. So let's check this next one. Okay, so I'm going to plug negative 1 in for x. Okay, 2 in for y. I get 2 times negative 1 plus 5 times 2. Okay, simplify that a little more. We have negative 2 plus 10. Okay, that is equal to 8. So it satisfies the first equation. Okay, now let's look at the second equation. Okay, 3 times negative 1 is negative 3. Okay, negative 2 times 2 is negative 4. Okay, so that's equal to negative 7. Okay, not 5. Okay, so this would not be a solution. So this is not a solution to that linear equation. Okay. Now we've talked about how to check to see if the solution is correct, but now let's talk about how to find the actual solution if you have the system of equations. Okay, below you'll see you have those 5 steps that you'll follow. Okay, so the first one is to solve one of the equations for a variable. Okay, the second step is to plug or substitute in that equation in for that variable in the original equation. Okay, step 3 is solve that equation. You'll have one variable left that you've solved for. Okay, and then the fourth step is to substitute or plug that number back in for the variable in the other equation. Okay, it's much more easier to follow if we do an example. Okay. So example 1. Okay, in this example, both of the equations are already solved for you. They're already in slope-intercept form, or y equals mx plus b. Okay, so we don't have to solve these equations. They're already solved for us. What we can do is go ahead and go to step 1. Okay, so since they've solved it for us, we've done step 1. Okay, so we can go to step 2. Step 2 is substituting this equation, the second equation, in for y. Okay, so now in the first equation, it's no longer going to be y. We're going to plug it in as x plus 5, because as we see, they're equal. So instead of using y equals 2x, we're going to say x plus 5 is equal to 2x. Okay, so that's step 2. Step 3 is to solve the equation. So now we're solving for x, the only variable we have left in that equation. So we have subtract x from both sides. Okay, now we have 5 is equal to 1x. Okay, so now I know one of my variables. Okay, so check. Now I go to step 4. Okay, so now that I know one of these variables, I can plug it back in to find the second variable. So now where y is equal to x plus 5, I know what x is, it's 5. So I can just put y is equal to 5 plus 5. Okay, so y is equal to 10. Alright, so now my final step, step 5, is to write my x value and my y value as an ordered pair. Okay, so my solution should be 5, 10. And if you plug in 5 in for x, you should get 10 out of your equation. So 2 times 5 is 10, check. 5 plus 5 is 10, check. Okay, so we found the solution using the substitution method.